Hello. So in this video, we're going to be looking at finding the area of a triangle. So again, if I have a triangle, say a generic triangle with points A, B, and point C, say, then how do I find the area, the sort of space inside the triangle? And we've looked at the cosine and the sine rule to do with the lengths and the angles in the triangle, but now we're going to look at the area. And the area of the triangle is given by the formula half. So if I label these sides, then so if this is the angle A, then the side is little a here. If this is the angle B, and then it's facing the side B, and then if I have the angle at C, then this is the side C. And so in this case, we say the area of this triangle, a generic triangle, is a half AB sine of the angle C. Okay, and that's the formula we will be using in this section. Okay. And actually, I will do a little proof of this. I didn't prove the other formulas we looked at, the cosine and the sine rule, just to save time. But this one's quite nice. It's quite quick. But I'll give this proof. Although, to reiterate, you do not need to know the proofs. The specification says you only need to be able to use the formulas. And we will be looking at examples in a moment. But a quick proof then. Well, we know the area of a right angled triangle is a half times base times height. Well, of course, the whole idea is with this, we don't have a right angle triangle. But if we then construct the perpendicular height, so the vertical height of the triangle from the top of it to the bottom, and so if we call this the height h, well, then the base is this b, right? So then the area is a half times the base times the perpendicular height h, right? That's the area of a triangle. But we need to get to this formula here. So this area with AB sine C. I have a half times the base B and the height H. But actually then, we've got a right angle triangle here, right? We got this. We got this right angle triangle, right? Um, and we know this is the length A. Well, if we use a bit of trigonometry, well, can we say that, well, this A is the hypotenuse, right? It's the side facing the right angle. And we got the opposite side of C, which is H. Well, that's the opposite, right? So we're going to use SOHCAHTOA, or the sine version. So therefore, the sine of this angle C is the opposite H over the hypotenuse A. Well, then we can just get H is A sine C. Well, then therefore then, this area, if we substitute this H in, is a half times B times A sine C. Which, if we just, I don't know, dress it up a bit, is a half AB sine C, right? And there we are then. So we can get that formula there. So I thought that would just be a nice little proof. Again, you don't need to know it, but I thought to give one in this section anyway. But yeah, so that gives me, well, obviously with any triangle, as we discussed, you can do a half base times height. But obviously you're going to need to know the vertical height, which should be here. But we won't always be able to nicely work out or be given the vertical height, which is where this comes in instead. Right, this half AB sine C, which gives us another way, usually a better way, of working out the area of the triangle. Right, so any triangle that is, well, any triangle whatsoever doesn't have to be a right angle. So there we are. And so we'll just be using this formula then in this section. So let's look into some examples then. So this example, work out the area of the triangle shown below. and we're given the triangle. So the area then, so in general, I think on the best way to sort of be able to use the formula is basically if we have two sides, A and B, and then we have the angle in between it, right? Then it's half AB sine C. So basically, when you want to look at the area of the triangle using this formula, basically you want to look for two sides and an angle between them. And so that makes you, and so these are the three sort of numbers we'll be using, the A and the B and the sine C. So basically we want to look for an angle between two sides, effectively, like in this case. But that's what we've got here. We've got two sides, this 4.2, this 6.9, and an angle between them. So that is the so that's where we can use the area formula here. So then the area then, well, it's going to be this half AB sine C. So then the two sides next to the angle, it's 4.2 here, and the other side is 6.9. And then we've got the sine of the angle. And so we just put that in the calculator, and then we get 13.996 blah 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 blah, which will round to probably best round up to 14, right? 14 centimeters squared. That would be do make sure you try to put your units in whenever you can, because we've got centimeters here. They can be a bit weird with the mark scheme sometimes. I've seen it. You need the mark when you put the units in as well. So it'd be centimeters squared, as it's an area quantity. And I'll say to the nearest decimal place. Or you could say 14.0, but it doesn't really matter. So there we are. It's 14 then, in this case. So yes, hopefully that's basically the idea of the formula, right? How we apply it. So let's have a look at another example. Okay. We are told in triangle ABC, AB is 5, BC is 6, and angle ABC is X. Given that the area of ABC is 12, and the AC is the longest side, find the value of X. Right. Okay. So again, with these sort of questions where you got a worded questions and sentences, I guess probably best to draw like the triangle, right, to see what we've got. So if I just draw a rough triangle again, so let's say this is point A, that's point B, that's point C. There we are. So AB is 5. There, BC 6, and angle ABC. So again, the B is in the middle here, so the angle's at B. That angle is called X. And we're also told the area of this triangle is 12. Now, actually, we know the area, as we see it, is a half AB sine C. And so it's the angle between two sides, but that's exactly what we've got. We got this side here of 5, and then this angle 6 next to this angle X. So then isn't the area we can say here is 12 is going to be a half times 5 times 6. So like the two sort of neighbouring sides to the angle, right? Times the angle X. And so actually we can solve for this angle X then, can't we? So if we just simplify this, so 12 is going to be a half times 5 times 6, which is 15. So we get 15 sine X. So therefore then, sine X is going to be 12 over 15. And so therefore the angle X we would get from this, if we inverse sine, is 53.13 ... degrees. Right, okay. However, I do advise you watch my previous video on the sine rule where we covered this in great detail, but we need to consider the ambiguous case again, because as we looked at last time, when we have sine of some angle, we get two angles in this case. This equation, sine x is 12 over 15, actually produces two possible angles. So the calculator gives me the first one, as always, but then remember, if you think back, the second one, we can use the sine graph to help us visualise this. So if we draw the sine graph between 0 and 180, so it would just be like that. So then the first angle we're given is, the first solution is 53, blah blah blah. So it'd be about there, say. So then if we read across the sine graph, the next solution for x would be about there. So then to get that next solution, because the gaps are the same at either end, here and here, so if we, in the first gap, from the first solution 53 to the edge of 0, well that's just 53.1 again, right? So the gap is the same either end. So to get from 0 to the first solution is 53.1. So then to also get from 180 back to this next solution, we take away this 53.1, take away the gap. So therefore the other solution is going to be 180 take away this. And as always, it will always be 180 take away the first solution, but the graph helps me to see that. So if I do 180 take away this, 126.869 blah blah blah, so that's the other solution. Remember, do go back and watch the last video on the sine rule I made, or wherever you want to learn it, because we do need to consider two solutions here. Right, okay, so we've got two solutions, and actually both are possible. We're not given enough information to rule out either solution. Well, we will. Well, in the sense that there's no other angles in the triangle, because remember when we looked at last time, we considered if the angles added up to 180, if they were above 180, we couldn't have that solution. But in this case, we only have this one angle x, so both of them are credible solutions. They're both valid. So which one do we take? Because it's only saying to find the value of x. It's singular. We can only have one of them. Well, it's this bit here. AC is the longest side. So basically, what that's saying is we want to make AC the side as large as possible, essentially. So it's bigger than the rest. So A's here. I've drawn it here. A's there. So AC is this length here. So this is facing the side X. In general, what you should know is sort of the length of the side corresponds to the side of the angle. Meaning, if we want the longest side, the angle opposite that side, so the X, has to also be the largest angle possible. Okay? Likewise, if we wanted, say, the smallest side, then the angle facing that side has to be the smallest angle in the triangle as well. What we're saying then is we want X to be as big as possible. So then the opposite to that, the side, would also be the largest side as well. So you want to take the bigger solution, okay? So to make, what is it, the side AC the longest side, we want to take the greater value of X. Well, therefore the greatest value is the second solution. So therefore x then is going to be 126, say 0.87 to 2 decimal places, and that is my solution there. So there we are then. So yeah, do not forget your ambiguous case, meaning you can get two different solutions from solving for an angle, because we've got this sine C, right? So I said up here in this little sentence here, because we have sine of an angle, if we're going backwards, because we're given the area in this case, and we're going backwards and using the formula to instead find the angle, you need to be careful when solving for the angle. So when we get to sine x is 12 over 15, we would actually always get two possible angles, okay? Because again, the way the sine graph works, they will always have two different solutions, two intersections in this case. So always be on the lookout for checking for a second solution when we're dealing with sines, okay? So anything to do with the sine rule or the area formula, we need to be considering that second angle possibility here. And yeah, I should also say as well, to clarify, if you had cosine of an angle with a triangle, you do not need to, there's no ambiguous case, because again, the way the cosine graph works, it looks a bit like that. So if I just cut that out and to only go to the first 180 degrees here, if I draw any line, it would only cross it once, so there's no second intersection, so there's no second solution. But anyway, anything with sines, so anything to do with the sine rule or the area here, AB sine C, if we want to find an angle, there will be two angles, okay? So anyway, so we'll just be on the lookout for that. So yeah, okay. And also again, to remind this little tip, again, the size of the angle corresponds to the length of the sides, right? So if AC is the biggest side, we want X to be the biggest angle because it's opposite that side. Inversely, if AC was supposed to be the smallest side, then X has to be the smallest angle in the triangle. So the opposites of the sides and angles do like correspond to each other. So again, make sure you're just aware of that. Okay, let's have a look at this exercise. More questions then. We are told in triangle PQR, PQ is x plus 2, PR is 5 minus x, and angle PQPR is 30. The area of the triangle is A. We need to show this area A is this expression. Okay, so first we'll be given stuff about a triangle. So again, let's just do a rough idea of the triangle, and then put our information in. And yeah, so we got, we don't have ABC, do we? We have PQR in this case. So PQ is x plus 2, that's up here. PR is 5 minus x. And angle QPR, so the angle's at P because P is in the middle, is 30. Right. So that, again, we're in a position we can use the formula half AB sine C. Because we got the angle and it's between two sides that we know, right? So therefore we can say it's going to be half times one of the sides, so x plus 2, times 5 minus x times by sine 30. And again, there's algebra, there's x's, right? There's not definite numbers, but you just do the same process either way, right? So we can simplify this a little bit because we can do a half times sine 30 first of all. That's going to be a quarter. So a quarter times this x plus 2 times the other bracket 5 minus x. Well then, we're actually quite close, aren't we? We've got this quarter, we're matching that part of the answer. Well, to get this x squared, well, just expand this bracket, right? So let's expand the bracket. We're going to get a quarter of, well, firstly, firstly x there is going to times by all the terms in the other bracket. So x times 5 is 5x. X times minus x is minus x squared. Then the same for the next term 2 here. 2 times 5 and 2 times minus x. Well, 2 times 5 is 10 and 2 times minus x is minus 2x. And so lastly, just collect all the like terms. We're going to get a quarter of 10 and 5x take away 2x is 3x. And then we have minus x squared. Well, there we are then. We got the exact formula. Cool. So that is A then. That's the area A. Cool. Then part B says, use the method of completing the square or otherwise to find the maximum value of A and give the corresponding value of X. Right, so you want to find the maximum value of this expression, effectively. Well, it gives you the hint, strong hint, it's completing a square. Because we've got a quadratic, right? We know how to find the maximum of a quadratic by completing a square. It's like the turning point, right? That sort of where the graph dips at the lowest or the highest point. So it's going to go like, because it's going to be a negative quadratic because it has this negative x squared coefficient. So it's going to have a frowny shape. Remember when we looked at sketching graphs? So this maximum is going to look like that at that point. But we can find this by completing the square. So we've got an x squared, we've got a quadratic part, so inside the bracket. Well, we've got this quarter, so let's just leave that where it is. And then we're going to have minus x squared, that's 3x plus 10, right? So then let's complete the square inside this part, inside this bracket. So then, remember, I firstly want to factor a negative out because I have a negative x squared. So I can factor negative out of everything. And so I'm going to have x squared minus 3x minus 10. And so in this point then, I have minus a quarter. I can factorise the x, complete the square, sorry, on the x parts. So remember, it's going to be x minus and then minus 3. A half of 3 is 3 over 2, all squared. Then we take away from 3 over 2 squared, which is 9 over 4. And then we have this minus 10 outside. Okay. And so we get over minus a quarter. And then if we just tidy this up, we have x minus 3 over 2. All squared. Take away 9 over 4, take away 10. That will get me minus 49 over 4. And there we are then. So then we can lastly times out this minus a quarter. So we're going to get minus a quarter of x minus 3 over 2 all squared. Then minus a quarter times minus 949 over 4 gets me plus 49 over 16. And so there we are then. We've got this in completed square form. So then we can read off the maximum value, right? Because the maximum value, or the minimum, depending on what quadratic we've got, always corresponds to when the bracket, the part of x equals 0. So this whole bracket equals 0 when x minus 3 over 2 equals 0. So therefore xn would be 3 over 2. And so then the value overall then, when this bracket is set to 0, so when this whole bracket again is set to 0, we only got left this 49 over 16. So therefore that is the maximum value. And so then that occurs when the bracket is indeed set to 0. Well, if we set the bracket to 0, that means x minus 3 over 2 equals 0, which means it's when x is 3 over 2. There we are then. So that's not too bad. I just picked that to refresh our completing the square knowledge we looked at earlier in the course. Again, if you need a refresher on that, I did a completing the square video. But with this spec as well, with the A level, topics do come up together and they intertwine. So do make sure you're constantly refreshing the earlier topics as well from in the course, because they tend to mix together. So yeah, okay, let's have a look at another question. This one. We are told a fenced triangular plot of ground has area 1,200 metres squared. The fences along two smaller sides are 60 metres and 80 metres respectively, and the angle between them is theta. Show that theta is 150 and work out the total length of fencing. So again, we've got this sort of like wordy description of a triangle. So we're told it's a triangular fence, a triangular plot of ground. So it's going to be a triangle. So let's draw a rough triangle. No, they didn't give us the names of any points. Let's just call it A, B, C. So we're told the fences along two smaller sides are 60 and 80. I mean, you can call that side wherever you want. Let's say that's 60 and say that's 80. And the angle between them is theta. So that's going to be there. Show that theta is 150 and work out the total length of fencing. Okay, so again, we're given the area is 1,200. So that's screaming I need to consider the AB half AB sine C formula because that's the area. Well then, we can use the formula because we've got two sides next to each other, next to an angle, right? This theta is in between two sides, so this means this area of 1,200 is going to be the half times one side 60, the other side of 80, and then the other, and then the angle sine of theta. And so then if we simplify this a little bit, 1,200 is going to be a half times 60 times 80. Which is 2,400 sine theta. And so therefore then sine theta is going to be 1,200 over 2,400, which is indeed a half. So therefore sine, if I do inverse sine of a half, I get the angle theta is 30. But I will always have to consider another solution, right? Because I'll get another angle again. So again, the other one, it helps me visualise, I can do the sine graph. Between 0 and 180. Again, I only need to consider 180 because that's what the angle could possibly be up to because it's in a triangle. So the first solution is at 30 here. So the other angle, the other solution for theta would be about there. So then again, the gaps at either end are the same. So that leads me to believe the other solution is indeed going to be 180 take away this. So it's going to be all theta is 180 take away 30, which is indeed 150. So that's my other solution. Well, actually, there we are, because it shows that theta is indeed 150. So again, you do need to be considering that ambiguous case, so that the other solution for an angle, because we needed to get to that particular solution. So we've got the solution of 150, which is what the question told us. But why exactly? Why have we got to rule out the 30? Just for peace of mind. So it's very similar to sort of the earlier question, because we're told the fences along the two smaller sides. That's telling me that this 60 and this 80, the side AB and BC, are smaller than AC here. So in other words, AC has to again be the largest side in this triangle, which means because the theta angle theta opposite to it, because AC is the larger side, that means theta has also got to be the larger angle because they're opposite. Which means we need to take the larger value of theta, okay? Which is why, so I'm going to say as AC is the largest side, theta must be the largest angle as well, as it's opposite it. So therefore, theta is 150, okay? So just a bit of justification there. But that's the idea, right? You need to be considering, in that sort of instance, that it's the largest side, so we need the largest angle opposite it as well. So that's why we take 150 for the solution there. But then it says work out the total length of the fencing. So we can actually say theta is now 150 here, if we wanted to. Well, work out the total length of the fencing, so it's asking for the perimeter, so all the sides. Well, we know two sides already, the 60 and the 80. We're just missing this AC, which I'll call X. How can we work that out? So now we're in a case where we've got three sides to consider and one angle. think about one of the two, the cosine or the sine rule. What could we use there to work out the total length of the fencing? To work out this side, right? What could we use to work that out? And hopefully you're screaming the cosine rule. Because again, the cosine rule, pretty similar to this half AB sine C. If we have an angle, again, 150, 60 and 80. If we have two sides and the angle between it, we can work out the other side that's facing the angle by the cosine rule, okay? So remember then the cosine rule is going to be a squared is b squared plus c squared minus 2bc cosine of a. Where it's the cosine of the angle. So we can apply the cosine rule to find this side A that's facing the angle if we know the two sides next to the angle. So it's very similar to the AB sine C, where we apply to when we got an angle and two sides next to it. But anyway, so we can apply the cosine rule to find this side X, right? By this cosine rule here. So if I do that here then, so then we can say X squared is then going to be the two sides squared, so the 60 and 80. So 60 squared and 80 squared. Take away 2 lot times 60 times 80 times the cosine of the angle between them, 150. And so if I do that then, I get X squared is this number here, 18313.843 not degrees, sorry, meters, is it? Yes, meters. So then therefore to get the side X, then we need to square root it. So if we square root that, I'll get 135.328 meters. Okay, so that's that side then. Well then it wants the total length of the fencing, so the perimeter. So we just need to add all the three sides then. So therefore the perimeter, or the total fencing, is going to be this X. Add the other two sides, 60 and 80. And that will get me 275.328 meters. So if I round out to say the nearest decimal place, 275.3. There we are. Cool. So yeah, hopefully start to see what we're trying to do here again. So again, the trickiest part maybe is realising you need to do the ambiguous case to find the second angle. So do always keep that in mind to keep finding that. Yeah, hopefully it's not too bad, that question. As I said, as well, they like to link multiple parts of the topics together, so it's not uncommon for exam questions to combine and you need to use multiple formulas. So like in this case, the cosine rule and the area of the triangle. We will be looking more about that in the next video, more trickier problems. But yeah, so talking of exam questions, let's leave off with this one. And we got this one. So we are told figure 1 shows a sketch of a triangle ABC with AB's 3x, AC's 2x and angle CAB is 60. They've drawn all that anyway. The area of the triangle is 18 root 3. Show that x is 2 root 3. Right. So again, it's talking about the area. So I'm thinking area is half AB sine C again. And I can apply the area formula because I've got an angle here, 60, and the two sides neighbouring it next to it, right? So then we could say, well, the area is 18 root 3. I'll do that down here. And then it's going to equal half times one side, which is 2x, times the other side, which is 3x, times the angle, so sine 60. So then if 18 root 3, if I simplify the right side, well, half times sine 60 is root 3 over 4. And then we're going to times by 2x times by 3x. And then I can simplify the right side even more, because 2x times 3x is 6x squared, times 6 by root 3 over 4. I get 3 root 3 over 4x squared, right? So then I want to solve for x, so then if I divide 18 root 3 by this 3 root 3 over 4, I get x squared, right? If I work that out then on the calculator, so I'm dividing both sides by 3 root 3 over 4. I get x squared is 12. And then therefore x then is going to be root 12. But we need to show it's 2 root 3. So we need to simplify the third then. So this goes back to our third knowledge. So see, lots of topics are intertwining together. Now we're looking at thirds. So root 12 then, we can split that up. Well, the calculator will tell you the answer. It simplifies automatically any thirds if we put it in. The calculator does give me 2 root 3. So we're right, but I need, I guess let's show it, right? Because root 12, again, we could split that up. If we look for square factor of 12, so 1, 4, 9, 16, so on. Well, 4 goes into 12, so it's root 4 times 3. And so, again, remember, we can split up two product of a third like this, individually. That's a third rule we looked at earlier. And then root 4 is just 2 root 3. So there we are then, so we get the answer. And I think that's in centimetres, is it? Yes, there we are. Yes, there we are. Cool, so that's part A. Fairly sort of standard exam question. Bit of algebra there, but hopefully that wasn't too bad. And then part B then says, hence find the exact length of BC, which is going to be this length here. Give the answer as a third. Right, okay, so again then, how we want to work out this other side, BC, here. So again, we've got a case then where we got 3 sides to consider and 1 angle. So that's going to be the cosine rule. We can work out this side. And again, we can use the cosine rule because we've got an angle and 2 sides next to it to work out the other angle, or the other side, it's facing the angle there. So then the cosine rule to find this length BC, I'll do it up here actually. So BC squared is going to be this first side all squared. Well, that'll be 2x, right? But we know that x is 2 root 3, so 2x is going to be 4 root 3. Oh. All squared, add the other side squared, so that's going to be 3x. But again, 3 times 2 root 3 is going to be 6 root 3, all squared. Take away 2 lots of 4 root 3, 6 root 3. But I could replace this to make it easy to see, where 2x is going to be 4 root 3 here and 6 root 3 there. But anyway, there we are. So we've got these sides now simplified because we know what x is. So then it's going to be cosine of the angle 60. And so therefore BC squared, the length BC, is going to be, if I put all that in a calculator, I get 84. So therefore then BC is going to be root 84. And the calculator tells me that is 2 root 21. So that third is then fully simplified. The calculator will always give you a fully simplified third in that case. So there we are then, 2 root 21 meters. Again, you could show it if you want to, because then root 84. Well, what 4 goes into 84, so it's 4 times 21. Well then, root 4 root 21. Well, root 4 is 2, so it's going to be 2 root 21. So I guess it could be very, very thorough. But I believe you won't get a mark for that. So I think you'll find to just jump from root 84 to 2 root 21 because the calculator will tell you that simplification instantly. But there we are then. So that's all the steps anyway. But there we are. So that's hopefully got a good idea how we can use that angle, that area formula, this half AB sine C. So yeah, so next time, as I said, we'll be looking at more trickier sort of examples, but hopefully you got a good gist now how we do the cosine, the sine, and the cosine and sine rule, and this half AB sine C formula for the area. So yeah, I'll see you next time.